Good morning, students. Welcome to today lecturing class. The statement is sketch the root locus for the system having the transfer function as k divided by s into s plus 3 into s square plus 3s plus 4.5. So, it is a similar problem which we have solved already. So, the number of poles we need to identify first. So, there are three terms, but for this term you are having two roots. So, the number of poles will be 4. There are no terms in the numerator, so number of zeros will be 0. So we need to identify their values. So s equal to 0, s plus 3 equal to 0, so it will be minus 3. And here if you find the root for this equation, you will get minus 1.5 plus or minus 1.5j. So this value directly you can get it from the calculator. So there are two roots for this one. So number of p is 4. So since p is greater than z, the number of root locus branches are 4. Now you need to identify the number of branches approaches to infinity. So p minus z you have to identify. So 4 minus 0 will be 4. So that is going to be the number of branches ends at infinity. So there are 4 asymptotes are required. For those 4 asymptotes, you need to identify the angles for the asymptotes. So for that, we are having the formulae theta equal to 2q plus 1 into 180 degree divided by p minus z, where your q value is 0, 1, 2 and 3. Substituting these values, you will get theta 1 as 45, theta 2 as 135 degree, and theta 3 is 225 degree, and theta 4 is 315 degree. For that, need to identify the centroid for those asymptotes. For that, there is a formula sigma equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. So the real part of poles are 0, minus 3, minus 1.5 and minus 1.5 because there are two poles here. Minus there are no zeros divided by p minus z is 4. To substitute that, you will get the sigma value that is centroid as minus 1.5. Then to identify the RL and NRL, first mark the poles. One is at 0, minus 1.5 and minus 1.5 plus 1.5j, minus 1.5 minus 1.5j. So take the reference plane here between 0 and minus 1.5. So we will get the summation of 4 poles and zeros is 1. So it is a odd number. So from 0 to this minus 1.5, it is a RL part. Similarly, if you take the reference plane between this minus 1.5, these complex poles, and this minus 3 towards the right side, you take the summation 1, 2 and 3. So it is also RL part. After minus 3 it is NRL, because if you take the reference plane here, there are 4 poles, summation will be 4. So after this minus 3 it is NRL part. So the part of axis between 0 and minus 3 is the RL. After minus 3 it is NRL. So now you need to identify the breakaway point. According to general prediction, your breakaway point should lie on RL, that is, it should lie on between 0 and minus 3. So to find that one, considering the characteristic equation, that is 1 plus g of s into h of s, substitute that value and simplify this equation to get the equation for k. So you get it as minus s4 s raised to 4 minus 6 s cube minus 13.5 s square minus 13.5 s. So differentiate this equation with respect to s and equate that one to 0. You will get the equation as 4s cube plus 18s square plus 27s plus 13.5 equal to 0. So now find the roots for this equation. Directly from the calculator you can get the roots as minus 1.5, minus 1.5 and minus 1.5. So if you observe all these values, they are lying between 0 and minus 2. So these all are valid breakaway points. Since their value is the same, so you can take them as the valid breakaway point. To cross verify that, substituting this s as minus 1.5 in this k equation, We get the value k value as plus 5.06. That means if we get this k value as a positive, that time we can take that point as the valid breakaway point. So all are valid breakaway points here. Then you have to identify the intersection with imaginary axis. So to find the imaginary axis, consider this fourth order equation which you already simplified here. This one s raised to 4, this equation right here. Then construct the roots array. For that, s raised to 4, s cube, s square, s raised to 1 and s raised to 0. Write their coefficients, consecutive coefficients you have to write. S raised to 4 is 1, leave this, 13.5 is with s square, then k. Similarly here, 6, 13.5, then it is 0. Here if you want to write for s square, already you have written this 13.5, so you cannot write here. So cross multiplication, this into this, 6 into 13.5 minus 1 into 13.5 divided by 6. If you simplify that, you will get it as 11.24. Similarly here, to get this k value, 13.5 into k minus 13.5 into 0 will be 0 divided by 13.5. So here it is 13.5 k divided by 13.5. So you will get it as k. Similarly, this one 11.25 into 13.5 minus 6k divided by 11.25. So here this term will be 0. If I take this one as a into k, 11.25 into 0 will be 0. So it is ak divided by a. So you are left with only k. So since this row k cannot be 0, so I will equate this term to 0, so that I will get the entire row as 0. From that you will get the value of k as 25.3125 is the k marginal value. Now consider the auxiliary equation, the row which is associated with the square term here. It is 11.25 square plus k equal to 0. In place of k, substitute this marginal value as the 25.3125. You will get s as plus or minus 1.5j. So this is the intersection of the root with the imaginary axis. Since there is a complex pole, as here you observe, this is a complex pole. So for this complex pole, you need to determine the angle of departure. For that, first you locate all the poles and zeros on S plane. Take this point as the reference point. Join all the poles and zeros with the straight line. So pi p1 will be 180 degree minus tan inverse of opposite will be height will be 1.5 divided by 1.5. So it is 135 degree. Similarly, tan pi p2. Sorry, pi p2 is vertical line here. So it is 90 degree. Pi p3 is here. Don't take 180 minus because it is an internal angle here. For this you have to take external. So that is the reason why I subtracted this angle from 180 degree. But here it is directly tan inverse of 1.5 divided by 1.5, which is 45 degrees. Since there are no zeros, no need to bother with that. Then pi equal to summation of pi p minus pi z. So it is 135 plus 90 plus 45. Zeros none, so it will be 0. So 270 degree is the pi value, and the departure angle will be 180 degree minus pi. So it is minus 90 degree for one pole, and for another pole it is plus 90 degree. After that, to plot the route on the S plane, first draw the S plane, mark the poles 0, minus 3, minus 1.5 plus 1.5j, minus 1.5 plus 1.5j. After that, mark the centroid. Centroid is minus 1.5. Then draw the angle lines 45 degree, 130 degree, 225 degree, and 330 degree. 4 asymptotes. Then locate the breakaway point. Breakaway point is at same. That is at coinciding with centroid minus 1.5. So your first route will start from 0 and it will come to this breakaway point. Then it will tend to infinity by following this asymptote. having the intersection with at my plus 1.5 j. Similarly, the second route will start from minus 3. It will come to this breakaway point. Then it will tend to infinity by following this asymptote and having the intersection at minus 1.5 j. So that the third one is starting from minus 1.5 plus 1.5 j is the starting point, and it will leave the path by having the tangential to this 90 degree, minus 90 degree. So again here it is coinciding with the same thing, and it will come to the breakaway point. Then it will tend infinity by following this asymptote. Similarly, this one will start from this point and it will leave the path at minus plus 90 degree, and it will come to this breakaway point. Then it will tend to infinity along with this asymptote. So here remember, all the routes are coinciding with your asymptotes. Okay. After that you need to write the comments on its stability. So if the k value is greater than 0 and if it is less than 25.3125, the system is stable. If k is exactly equal to 25.3125, the system is marginally stable. If k is greater than 25, then the system is unstable. So here, while determining this angle of departure, you have to be careful. First, you have to draw this, then determine the individual angles, then take the summation of those angles, then find the value of pi, subtract that pi from 180 degrees so that you will get the departure. In the same term here, if this second order term, if it is in the numerator, that time you have to identify angle of arrival. Okay. So if you have any doubt, you can leave the comment in the comment box.